Okay, what we're going to do is we're going to construct a parallelogram, okay? The parallelogram is going to be A, B, C, D. That means A links onto B, B links onto C, C links onto D, A back to D back to A. Has to be in that order or something like that, okay? Basically A is opposite C and D is opposite B. One letter gap, yeah? Everybody cool with that? Now, always works that way. Now, we're going to start off with the longest side. I prefer to start off with AB being I actually need that. So, AB being 8 centimeters. So I'm just going to draw 8 centimeter line. Enlarge this slightly. There we are. So, and we'll go down a bit lower. Okay, 8 centimeters. 8 centimeters from there to there. No hassle, okay? Now we're done with that. What it wants to do next is, it says the angle BAD. So remember it said, I'm just after drawing A to B. So that means BA all the way up to D is that angle there. So what angle is it? 70 degrees, okay? So with the 70-degree angle, I'm going to need myself a protractor. So I get the protractor, bring it down here, and then draw that 70 degrees. 70 degrees is the same thing as 110. So we just do a little line there. Now, I then draw a line up through there. Now, I don't know how long that is. It doesn't particularly matter because I'm going to measure it out in a second anyway. All what we know is that this line is at 70 degrees. We know that the line BC, so would you understand that BC is obviously opposite? BC is opposite AD, isn't it? Okay? So that means that you can also write down, look, that means that A to D must equal 5. So how long does this have to be? 5 centimeters. So I go to my compass, and what I do next is I mark out 5 centimeters on this length. So start here, go across. Now I have 5 centimeters. Bring it down to the corner, up it goes, and that line there marks 5 centimeters. Everybody right with that? Now I can repeat this procedure further down. Actually, as it turns out, could have brought it down to the other one. Once again, what type of length am I looking to do? What type of angle am I looking to do? 70. So mark that up at 110. Once again, do the same system. Draw a line that goes through the 70-degree mark longer than you need it. Bring over your compass. Mark out 5 centimeters. There. Now how to complete the parallelogram? Join that one to that one. Now you don't get marks if they don't see those construction lines. You lose marks. I've also lost marks for the following reason. I didn't mark in my diagram A, B, D and C. So A, B, C, D. Yeah? Now, once that's done, what else do we need to put in? Put that at 70 degrees. Then, length, that's 8, 5, 8. That's all the information they gave you up at the very top. So that means you're done there. Okay. Now, the next three are the most popular three. The tangent, the circumcenter, the centroid, and the incircle are the most popular constructions in the last couple of years in the Leaving Cert. I assume this year is going to be no different. So, what we're asked to do is steps to construct a circumcenter and circle of triangle ABC. So what we're going to do is this. I'll do 2 examples of this because you're going to need to see 2 examples. The first example will be an acute triangle, like so. You can see that they're all acute angles, yeah? When they're all acute angles, it means the center of the circle is going to be within the triangle. When it's a right angle triangle, the center of the circle is going to be on the hypotenuse. When it's an obtuse angle, the center of the circle will be outside. You'll see that in a minute. Okay, step 1, you get out your compass, And what you're going to do is you're going to draw perpendicular bisectors of two sides. Everybody remember to do a perpendicular bisector? How do you do it? Anybody remember? How do you do a perpendicular bisector of this side here? Bring the full thing down. Sorry? Just make it slightly bigger than halfway. After that, above and below. One above, one below. I'm going to make the arcs a bit bigger because yesterday I constantly didn't make the arcs long enough and had to go back a couple of times. What is up with that? There we go. Going to do the same thing over the other side, maintaining the length. By the way, if you've already done TG, you can be on your papers right away. Don't need to listen to me. Okay. Now, only if you've done leaving cert TG, you wouldn't have done the Centroid and Circum Circle or tuning cert. Okay? Yeah. Now, I've done this. What do I do with those two lines? Huh? Join them together. And what exactly does that do? It creates a perpendicular line going through the midpoint of that side. I'm going to repeat the procedure. This time I use blue. I'll pick any other side I want. I'll make it a bit shorter. I'll use. I'm going to go for the bottom side. So this side here. So I'm not over halfway, which is a problem. Now I'm over halfway. Okay. So I'm just going to do an arc above and below. Now you can see there's a bit of gets a bit sloppy after a while. Like there's lots of different lines there. That's just no avoiding that really. Okay, then I'm going to change sides, bring it down to the other point, and do the same thing. Okay, so I'm just here, and that's one above. And unfortunately, I've done that thing again where I didn't make the last arc big enough. So gotta go back to the previous one, back up there, and just finish off my arc. There you are there. What do we do with those 2 points? Join them together. And you keep going through. Where did the two black lines hit each other? Dead center there, yeah. Now, what you're going to notice next is that if you were to draw a circle from here, so I'm going to do it in green now, go to the center of your circle and point at one of the angles. So move it until it's directly on one of the points. And what should happen when you draw a circle here? Should go through all three. Now, if this were an exam, I've lost marks. Can anybody tell me where I've lost marks? Doesn't go right through all three of them perfectly. Okay, that's all to do with accuracy. That is just little things like, did I go slightly to the left? Did I go a millimetre to the left? You're literally talking millimetres here. A millimetre here and there results in the diagram not drawn as good.
If the circle's not a perfect circle and you find it,
circle will always be a perfect circle. Sometimes it just won't hit the triangle at one point only, which means you've made a mistake or you haven't done it properly. Lads, go and do this one more time. Except this time, it's going to be a acute angle. Obtuse triangle. Okay, so this full thing here, disappear. And this time we're going to work with an obtuse triangle. So an obtuse triangle, you have one very large side and then two shorter angles. Please remember last time we had something like this. See this one to the right? See the way the centre of the circle is inside the triangle? Now look at this example. Okay, so I'll just delete that. Same procedure as last time. What is the procedure for the circumcenter or circum circle? Okay, we're going to have to draw some bisectors. So we'll just I can start off like this, I suppose. Am I above halfway? No, so I need to make it just that little bit longer. Okay, there we go. So one above, one below. Here's one below. There's one above. Okay, change sides. and go again. One above, one below. Now see the location on my tip here. Even that being slightly out introduces minor errors further on. Okay, and just enough there, yeah. Okay, now I'm going to go for red. We're going to do the same thing, except we're going to pick a new side. I'll actually join those points up with a ruler first. Now, I'm slightly off there. I can't adjust that 1 millimeter to the left. Okay, just the settings on the computer for some reason. Okay, and now I'm going to do the red one, another side. So I'm going to do this side here. I seem to be a bit on the long side at the moment, so I'm going to make sure it's perfect and move over halfway. One above, one below. And then one above and one below again. That actually hurts my soul. Now, there we go. Now, even something like this, guys, like that shows you. See the way there's two separate lines there? That shows you it wasn't in exactly the same position twice. You need to be very careful about that. Okay, make sure you're exactly on the out tip of it. Now, going to draw this line upwards, go straight through. Now look what happens this time. This time, they intersect outside the circle. Okay, now what's going to happen this time? Okay, put this here, and then you're going to once again go from this point to one of the angles, or one of the corners. So go to the nearest. Well, they're all equally as close, or they should be. So let's see what happens this time. Now I missed one corner. Two of them are perfect, but the third one slightly out. The main thing to know here is that the centre of the circle is actually outside the triangle this time. Now what is this? It's a position. This is a position here that is equidistant from your three corners of your triangle, or should be. It's equidistant, which means it's the same distance to all three corners of the triangle. Is that alright? That's the whole point of a circumcenter. Next one. Okay. The in center and in circle of a triangle. This is where a circle is fitted inside a triangle. Is everybody okay with that? You fit a circle inside a triangle such that each side of the triangle is a tangent to the circle. They're all tangents to the circle. Does that make sense? Okay. Okay, guys. Here's what we're going to do. We have a triangle. Okay. And what we got to do is we got to create a circle that fits into this triangle such that all three sides are tangents. Otherwise known as the in center is the center, in circle is the actual circle. So here's what we're going to do. We're going to bisect we're going to bisect two of the angles. Do you know what I mean by bisect an angle? What does that actually mean? Cut the angle in half. So get your tip here. Excuse me, guys. Pick a length, keep it the same length. 1, bring it down, 2, then move it to the first 2. There's another one. Bring this one down up here, bring it up. There you are there.
What's this one called?
That's called bisecting an angle. The actual full construction is called the in circle and in center.
Is that bisecting?
That's bisecting an angle.
An acute angle then?
Yeah, bisecting. The angle is acute, and we'll bisect it. Now, guys, you're going to see something. I've actually done a slight inaccuracy here. Can anybody see that? It's slightly closer to the bottom than the top. Once again, that leads to a little bit of inaccuracy later on. Make sure you're really precise with your pencil. Okay? Much easier when you're on pen and paper. Okay. So that thing there, you can see the way it's not exactly equal top and bottom. Now we can try the second time maybe. See if we can do it better this time, but sometimes the calibration, yeah, does have to do the same thing more or less. Even worse this time. There, that's a bit better. Okay. Now we're gonna do another one. This time I'll change to whatever, blue or something like that, just to signify what I'm doing here. Okay, go again. Up the top, bisect this angle. Make sure you're right at the corner. 1, bring it down. 2, up. You can actually do it that way as well, but it's just messy. 1, and then just make sure you're there, and then there you go, and ready to go again. Now, do you see where the two of them hit each other? So we're going to colour this green. That is the in centre of the triangle. You got that? The in centre. If you draw a line going straight down, that is the radius of the in centre, because it's going straight down. Then you get your compass. What you do is you mimic that length, so it's going straight down. And what I'm going to do next is I should be able to draw a circle. Okay, now we can obviously see just slightly off on all fronts, but it should be tangents. Okay.
So the edge circle, then you just put it to the angle, is it?
You just get middle of the angle, middle of the angle, and where the two of them hit each other is referred to as the centre of the circle.
That's not what I asked for.
What?
I said if you were to get the outer circle.
Okay, guys, this one's called the centroid. This one's called the centroid of a triangle. Okay. To get the centroid of a triangle, here's what you're going to do. In the test, you're given the triangle. Okay? And the centroid is very similar to the circumcenter in some ways. The centre of gravity has to be within the triangle. Would everybody agree with that? Centre of gravity has got to be within the triangle somewhere. It can't be outside the triangle. It's impossible. Okay? So for the centroid, it has to be inside the triangle. Okay, so here's what's going to happen. We're going to perpendicular bisect two sides. So we'll start off with one side. Okay. Okay, guys. So moving up, everybody remember how to do a perpendicular bisector? Above and below. Cut above, cut below. Most common one.
Does it matter how much over the halfway?
No, it doesn't matter at all. One.
Would you have to keep the same distance up and bottom?
Yeah. Never change the distance. Now, do you see where it hits the centre, the midpoint? Yeah? You're then going to have to draw a new line. And you know where the new line's going to go? The new line is going to go to the opposite angle. So, red one here joins all the way to that angle there. So the red line's the one I'm interested in. Okay? You get the middle. Once you get the middle, then you join it to the angle that looks at it. Okay? Try this one more of them. We'll go blue this time. Okay, oh sorry, that was a line. We'll take the bottom side. It's an easy one to do. Okay, bisect the bottom side. So, above and below. One above, that's one below. I think it's reasonably large. One above. Change that around. One below. Then one above. See where the two down hit? That's going to give me once again my settings, unfortunately I'll just have to draw this freehand, which I'm not too fond about, but we'll give it a go. No. Yeah, I know, something to do with the settings. Either way. Okay. Either way, I'm just looking for the bisector. I'm just going to draw it where it should be, just slightly to the left of that. Now, what do I do with that point? I draw it to the opposite angle. Okay, so I draw that to the opposite angle, which is going to be up there. And then see where the two of them hit each other? That there is the centroid.
There's loads of lines on the wall.
Yep. Yes, there is.